Hello and welcome to the AICE Chemistry lecture series. In this video, we're going to finally start the very last chapter of our AICE Chemistry curriculum, which is chapter 18, covering carbonyl compounds. So remember, carbonyl compounds are a subsection of functional groups, meaning that I involve a few of them, including aldehydes and ketones, which are the main functional groups we're going to see in this chapter. There are 7 sections in this chapter, although we do have one bonus section that we kind of skipped in chapter 3. But in chapter 18, with the carbonyl compounds, we are going to see first just what are the homologous series for those main carbonyl compounds in this video, which are the aldehydes and the ketones. We're then going to, like usual with organic chemistry chapters, going to go into how do we prepare or make aldehydes and ketones through which reactions. And then we're going to go into the different reactions of aldehydes and ketones. We're going to see the reduction in section 3, the nucleophilic addition with hydrogen cyanide or hydrocyanic acid, depending on how you want to see it, in section 4. And then in section 5, we will go into how do we test for aldehydes and ketones. How do we figure out if an unknown has an aldehyde or a ketone group. Finally, finishing with a very specific test in section 6, which is the triiodomethane or triiodoform test. In section 7 and 8, 7 is going to focus on a specific type of analytical tool called the infrared spectroscopy. And this is not unique to aldehydes and ketones. Infrared spectroscopy is going to cover a wide variety of organic compounds and how do they show up in infrared spectroscopy. And then in section 8, we're going to see organic mass spectroscopy, which if you look in your book, there is no section 8. This is actually from chapter 3, a section that we skipped because we had not yet done organic chemistry that we're now bringing back in this chapter once we finish all of organic chemistry. So let's get started with section 1. Section 1 is just going to cover very quickly, so it's going to be a short video, the homologous series of aldehydes and ketones. So remember, homologous series is just simply how would we look at a functional group like aldehyde or ketone if you have more and more carbons, increasing numbers of carbons. So we're just going to see the basics of these functional groups in this section, which is very short. So aldehydes and ketones both fall under the group of functional groups known as carbonyl groups. So carbonyls, or the carbonyl group, is the carbon double bond oxygen part of different functional groups. And we talked about this in chapter 14. Carbonyl groups can be aldehydes, ketone, esters, or even carboxylic acids. In general, the carbonyl part of the group is going to be that carbon double bonded oxygen that we have in all of these functional groups, with the difference coming in the two things that are bonded to that carbon. We'll call it just R and R prime because those change from functional group to functional group. Now, what makes an aldehyde and a ketone different, because they both have carbonyl groups, is what those R's are. So aldehydes, primarily, actually let me do this in green, aldehydes are going to be or have terminal carbonyls. What does that mean? The carbonyl on an aldehyde is at the very end of the carbon chain. It's on the last or first carbon. So where that carbonyl is present in the aldehyde, carbon double bond oxygen, that's going to be either the first or last carbon of the group or the chain. And then it's going to have a hydrogen on one side. That's why it makes it terminal. There's no continuation of the carbon chain. It just ends right there on that carbonyl carbon with a hydrogen next to it. And then that other R group could be anything from hydrogen to a carbon chain. Could be really anything there. So because aldehydes are terminal, the carbon that the carbonyl is on is always going to be carbon 1. So if I draw a few aldehydes here, Let me get my pen. So if I draw a few aldehydes, they're always going to have that double bond at the end. So that's an aldehyde. This could also be an aldehyde because the carbon double bond oxygen's at the end. These are both types of aldehydes. This is another aldehyde. But that carbon that the carbonyl is on, this is always carbon 1 for the aldehyde. So a lot of the time when you see aldehyde names, they don't have a number because we know that carbonyl carbon is, that aldehyde carbon is on carbon 1. Aldehydes are changed by naming the ending to Al. And so if there is no double bond, they're single bonded, we're always going to have that Al with an An before for the alkane part. So methanal, ethanal, propanone, butanone, pentanol are all our aldehyde homologous series, where that CHO, which represents the aldehyde, is always on the terminal carbon, meaning either at the beginning, really at the beginning because it's carbon 1, but either at the beginning or at the end of the structural formula. So that's aldehydes. They have the carbon double bond oxygen at the end, so they have a hydrogen on one side with a carbon chain on the other. A ketone, on the other hand, is not going to be terminal. Ketones are carbonyl compounds or carbonyl functional groups where the carbonyl compound is somewhere in the middle of the chain, meaning that we have that carbonyl group in a ketone, the C double bond oxygen, just like we do with the aldehyde, but on either side of that carbon, there is more carbon chain instead of one side having a hydrogen. So ketones cannot be terminal. Essentially, ketones are the non-terminal version of aldehydes, or we can say that aldehydes are the terminal version of ketones. So ketones are going to be named by changing the ending to O and E. So let's draw a few ketones first, and then we'll go into the naming. So ketones might look like this, where the double bonded oxygen is in the middle of the chain, not at the end. And again, we can have branches and whatnot. We could have a branch there and still have a ketone. We could have the ketone further into the chain if it's longer. We could either have the ketone here smack in the middle of the chain. The only place we cannot have the ketone is at the very end of the chain. So this carbon, this carbons, this carbons, these could not have the carbonyl group on them, the carbon double bond on them, because that will make it an aldehyde, not a ketone. So with the ketones, we will have numbering unless it's a very short ketone, because we need to know where the carbon double bond oxygen is. Here, that carbon double bond oxygen is going to be found on the 1, 2, 3rd carbon. Here, it's on the 2nd carbon. Here, it's on the 2nd carbon. Here, 1, 2, 3 is on the 3rd carbon. So a lot of the time with the ketones, we are gonna have that numbering, and the ketones are named by putting an O and E at the end of the chain. So propanone, for example, we have that O and E, but we do not have a number. Why? Propanone only has 3 carbons. That carbon double bond oxygen has to be in that 2nd carbon. There's no other choice. Because if we put the double bond oxygen here, that wouldn't be a ketone, that will be an aldehyde. And the same thing with the other carbon. So that one doesn't require a number. Butanone, same thing. 1, 2, 3, 4. The carbon double bond oxygen can only be on the 2nd carbon, because it's either on this one or this one, which will become the 2nd carbon. It will just be this same molecule but flipped over. Once we get to 5 carbons, then we need numbers. Because pentanone, which we have here, 1, 2, 3, 4, 5, can have 2 different versions. There's 3-pentanone, which is right here. So this will be 3-pentanone, or 2-pentanone will be, let me draw it up here, somewhere in space, 1, 2, 3, 4, 5. This will be 2-pentanone. So these are not, this and this are not the same molecule. So we do need to number, because this carbonyl goes in carbon 3, this carbonyl goes in carbon 2 on a 5-carbon chain. So this pentan 2-one or 2-pentanone and pentan 3-one or 3-pentanone. So the carbonyl, unlike the aldehyde, which has to be terminal, the ketones can have numbering. They can have different locations. So that's the aldehydes and ketones, which are the most basic or the primary functional groups for the carbonyl subgroup. All right. That's it for this very short section. I will see you all in section 2 to start discussing the reactions that make aldehydes and ketones.